So in this module, we will be discussing the optimization and training process in 3D Gaussian splatting. So basically, we will be understanding step by step like how a 3D Gaussian splatting model it transforms random blobs into a photorealistic scene through optimization. Because we know the basic idea that okay, we have millions of 3D Gaussian, they are like ellipsoids, and each Gaussian will be having parameters like the center of the ellipsoid, we call it the mu, the mean, and then we have the covariance matrix that contains information about the scale, orientation, rotation of the 3D Gaussians. We have opacity and color in the form of spherical harmonics. So all this information of a particular Gaussian. So like that, every Gaussian will have these parameters, which will represent how it looks in the 3D world. So that's the idea that we already discussed. Now let us suppose if millions of Gaussians, if every Gaussian is been given random parameters, then definitely it will form a scene, but it will not be significant for us because it will be something random, some random scene, random 3D scene it will make. So in order for us to render a scene of interest, we have to train it. And that is what we will learn, how we can train the parameters. Train means we have to learn the parameters. Every 3D Gaussian, we have to learn the parameters to achieve a value that will give us a scene which we are looking at. So that is training. And for training, we will be doing the optimization. So random 3D Gaussians, millions of Gaussians, they will be converted into photorealistic scene through optimization. So that is what we will be discussing. So 3D GS training, 3D Gaussian splatting training is that what we will be discussing now. From random blobs to photorealism, that is the optimization pipeline. So we will follow a pipeline. We are calling it the optimization pipeline. The idea is that initially we will be having random blobs. Random blobs means we will be having 3D Gaussians wherein every Gaussian will be having random values for the parameters, and hence we are calling it random blobs. And those blobs, when combined, they will represent a scene that will be some random scene. So that is the initial scene representation where we will be starting with. Then using that random blobs, we will render a image and we call it the predicted image. And definitely predicted image will be very different from the ground truth, from the real image. So we compare the predicted image or the rendered image with the ground truth. And with this comparison, we will be able to compute the loss. So because the loss is like the difference between the real and the rendered. So two types of loss we will compute, L1 and LSSIM. L1 is basically the pixel difference and LSSIM is about the light and feel, like the look and feel of the image, like the lightning and all that. We'll look at in some detail what exactly is LSSIM. So we compared the rendered image with the real image, the ground truth, and we compute the loss. And this loss will be adjusted. So we will adjust the parameters in such a way that to minimize this loss. And that is what is optimization is. So then what we will do is that whatever the 3D Gaussians, the random parameters it had, we will update the Gaussian parameters. And when we will update the Gaussian parameters, the scene will change, and once again we will render the scene. Like we will render the predicted image, we'll compare it with the ground truth, once again compute the loss, and we'll keep on doing it until the loss is minimized. And once the loss is minimized, we will reach a state wherein the predicted image will be very close to the ground truth. to the real image. And that is what is the optimization pipeline is. So optimization pipeline is basically a process wherein the 3D Gaussians, they will render a image of our interest. Rather than rendering something random, it will start rendering a scene which we are interested in. So optimization pipeline is all about learning parameters or training, wherein we will train the 3D Gaussians to learn the parameters. They will learn the parameters. So basically, the main goal now it's very clear that we will learn how training works in 3D Gaussian splatting. You got a basic idea, but we will discuss in some good detail. Like in-depth discussion we will do. So the key insight is training is equal to iterative improvement of the scene representation until rendered images match real photo. So we will iteratively keep on improving the scene, keep on updating the parameters, keep on improving the scene until the rendered image match the real photos. So what exactly we are optimizing? That's a very important question in front of us, that what are we exactly optimizing? So we know that for every Gaussian, we have parameters, like we have position. So we are optimizing it. We have covariance matrix, which represents the shape and orientation of the Gaussian, of the 3D Gaussian. We are optimizing it. We are optimizing the color, which is represented as spherical harmonics. And we are also optimizing the opacity. So that is what we are optimizing. So we are optimizing these parameters so that every 3D Gaussian, like it takes a form which which when combined, the predicted image or the rendered image, it is very close to the real image. That's the goal. So the goal of optimization is to minimize the loss. So for ith Gaussian, the rendered image should be equal to the ground truth. So the idea, so this is the loss. Loss is like the, we know now how to calculate the loss. L1 plus L SSIM. So the goal is to minimize the loss. The minimize argument is there. And theta is like for all Gaussian parameters. So for all Gaussian parameters, we have to minimize the loss. So the idea is that we have to update or adjust the parameters. We have to keep on doing it until we minimize the loss function. So that's the main goal of optimization problem.